Let's start. I hope I should start my timer. So I have 40 minutes. I hope I can do it in 30, so I have some time left for questions afterwards. My name is Pascal Serrarens. I'm the owner and founder of Passer VR, and my company is concentrating on animating, controlling human avatars in 3D environments. 25 years ago, I studied artificial intelligence here at the University of Amsterdam. And actually, what I wanted to do is create virtual humans. I was a fan of Isaac Asimov's stories about robotics, humanoid robotics, and that's what I wanted to do. However, the study of artificial intelligence was a lot about neural networks and stuff which is quite known now these days. But I was actually more focused to the humans. How do they work? How do they move? And how can we copy that into a virtual environment? Well, I stopped with that. I did a PhD in computer science, went into business. But 5 years ago, I got some hand trackers on the market for very cheap. And suddenly the spark came back. Virtual reality appeared. And a lot of devices and technology came onto the market, which relighted my passion for virtual humans. So these days, I'm fully working on virtual avatars. I have a company which develops the software for human avatar control. It's used by hundreds of developers around the world. And today, I'm going to talk about a bit of what's behind the scene of avatar control these days. So we all know about animation, but these days we can move ahead further than that, and that's what I'm going to talk about. First, I'm going to talk about motion capture. There are a lot of things going on in the area of motion capture, especially for budget motion capture. I'm going to talk about sensor fusion because that's a major technology nowadays, and it shows that we can improve ourselves with code to improve body tracking with sensor fusion. I'm going to talk about artificial behavior. That's actually, for me, the part of artificial intelligence which is really interesting because it's about how we work, not what we think about, but what we do and why we do that. And the last topic today will be about physics, because physics in combination with animation is a challenging thing, and I have a solution for that, which I want to share with you. So motion capture, you maybe know about the huge, expensive film-oriented motion capture scenes, which cost $10,000s or even millions of dollars to set up. It costs a lot of time to set up, and it costs a lot of space to do. So people are looking for cheap alternatives. And a couple of years ago, the Kinect came onto the market, which has a very low entry to the market of 150 euros, giving you the possibility to do motion capture. However, people were quite disappointed about it. It was quite limited. You have to stand in front of you. It has a small area which can be tracked. But still, for a lot of applications, it's a useful tool. And a colleague of mine, Jasper Brekelmans, has created a motion capture software solution for that. And it can work well. But what we are really looking for is real body tracking. Well, you've seen my kit today already, of course. What I'm wearing today is a motion capture suit, which is from Perception Neuron. And actually, it's based on technology from cell phones. So every sensor on my body is actually tracking rotations of my body. Every joint is tracked directly. And when I go to this screen, you should be able to see I've walked away. So where's my mouse? It's always gone. And my left leg is also gone, so I see. There's my mouse. Oh, keep steady, sorry. Still, my left leg disconnected somewhere, I see. But you can see, you can actually follow me directly, and you can make recordings of this. So, next to that, I'm actually wearing, at this moment, a Vive tracker. Vive, HTC Vive, is a virtual reality headset, and it's quite popular in the community. However, this year they came out with independent trackers. So this is actually, this puck is a point which can be tracked in a certain space. You need some additional lighthouses set up. I didn't set them up, so I'm actually not using this. But it's a cheap introduction to motion capture. And actually, you can do quite well capture with that by putting multiple of these trackers onto your body. So I have a video from Kinematic, and it should. There it is. And now I have to find my mouse again. Kinematic, which is actually using 6 of these trackers. One on the head, 2 on the hands, 1 on the hips, and 2 on the feet. And you can see that you can already get a quite well tracking of the body with just tracking 6 points. In contrast to the motion capture suit I'm wearing, it's actually 20 points at the moment. So this enables a new level of motion capture, which doesn't cost $10,000 or even millions of dollars. This is about the price level of $1,000, and it enables you to do all kinds of captures yourself for small-scale projects. Another thing is that it's quite small and easy to set up, so you can do a quick capture. So instead of in place of doing keyframe animation or buying motion capture packs, you can now record your own motion capture. And now I have to stop it. Yeah, and go back. However, even those systems have their limitations. They cost quite a lot of money for a cheap one, but for normal developers, it's not a huge amount. But they have limitations. For example, the perception neuron pack is depending on rotation sensors. And that means that it calculates, or it sees the rotation of my shoulder, sees the rotation of my upper arm, my forearm, and my hand, and then calculates where my hand should be. However, it doesn't know the length of my arms, and there are all kinds of errors in tracking of this technology. So for example, if I can switch back again to this one, and I place my hand on my head. Oh, this is not too bad, actually, today. Usually, this one is also quite difficult. You see that the hands are not actually touching each other. They are moving through each other. And that's because it doesn't know the length of my hands and all kinds of errors in that. So it is able to do very nice, smooth captures. It could do it even wirelessly. I'm using a wire today because in situations like this, wireless is not very reliable. But you can even put in a memory card and go walking 10 kilometers through the village or something like that. You can do it any way you want. But like I said, positional tracking is difficult. This one, it only has 6 points. So it's not able to track your fingers. This one has a glove with finger tracking, for example. What it doesn't track either is movements like this, because it doesn't have any tracking on the arm further than that. So how do you move on from that? And that is where sensor fusion comes around. And in this case, I'm going to show you a bit about a combination like this, with one tracker on the arm and the perception neuron for the arms. So actually, what my software does is it inputs all sensors available. So in this case, it's just 2, but it can be a lot of them. Actually, this is the list I'm currently supporting. And you see Oculus Touch, you see Razer Hydra, Kinect, it's all supported. And actually, you can use them all together at the same time to get an optimal tracking. And how it does that is where every sensor is looking to the current tracking result and see if it can improve on that. I'm going to take the perception neuron tracking as an example. After a sip of water. So actually, this is a very small snippet of the code. You see that for the neuron tracking, it's first it looks, do we have a reliable tracking of the hand, the positional tracking of the hand? For example, with the HTC Vive tracker. If we do have a very reliable tracker, I'm going to use that information. If I don't, I'm just using the input from neuron directly. So, but when we have a position of the hand, how do we combine the information from the neuron with the position of the hand? How do we correct this information? Well, for that, we need a technology called inverse kinematics. And I'm going to explain a bit about it because it's a simple and beautiful. And for me, it was very nice to see that the mathematics of high school still work in real life application. So what you do with inverse kinematics is you first orient the upper arm to the target. So first I'm going to orient the upper arm to the target I'm going to point to. And then actually I'm rotating the whole hand such that the hand of my avatar is at the position of the tracker. So this will then give you the required position of the arm. And the solution for that is the cosine rule. I don't know whether you recall it from high school, but it's a very basic mathematics rule which is taught over there. And it says, well, if you know the length of A, B, and C, you can calculate any angle in the setup. And we know A and B because it's the length of the arms. We know the length of the arms of the avatar. We know the length, the distance from the upper arm, which is here, to the target, because we know these positions. And then we can calculate alpha, which is actually the required rotation. However, it's a partial solution. It works in 2D. In 3D, we still have more degrees of freedom. So for example, I can still do things like this. I can rotate around axis C and still reach my target. Actually, when you do this for avatars, you will also see that the lower arm can still rotate in awkward ways. So we need to solve this thing completely for 3D solutions. And that is actually provided by the neuron, because the neuron is actually very good at tracking the rotations of the lower arm and the upper arm. So when we look at the code, then you see for the lower part, this is for the forearm. The forearm is just looking at the hand position, and we use the neuron forearm information to get the rotation along the forward axis. So the rotation along the forearm itself. The upper arm is a bit more complex because, like I said, we are looking at the target, and then we have to rotate, and that exactly, the arm IK is an implementation of a cosine rule. So in that way, you can combine multiple tracking solutions, and in this case, can be it's a tracker, but it could also be Oculus Touch or any other positional tracking device, and then have the best solution for tracking at your fingertips. So you can improve this by code, integrating multiple sensors. So okay, that's a quick introduction to tracking, sensor fusion. The next thing I want to talk about is artificial behavior, because I'm very excited about it myself. Artificial behavior, like I said, it's a kind of low-level artificial intelligence. I don't like the high-level intelligences or expert systems and learning algorithms and so on. What do people, when they are waiting for the bus? Yeah, nowadays they are looking at their phone and doing nothing interesting. But even when you do nothing, a lot of things is happening in your body. You're looking at things, not consciously, but just looking around. Your body moves in situations like that. It's not that you're still or doing the same animation over and over again. No, you're having behavior. And actually, this is a very strong thing in virtual reality, because when you do human-like things, we're actually closing the gap, the uncanny valley, as we call it, between artificial humans and real humans. And the first time I saw this was actually this demo. It's quite dark. I hope it will work here, because this was in virtual reality. It was a girl in front of you. And the only thing they did with her is head animation and eye animation, but then implemented as coffee without words, as human artificial behavior. So I'm going to show a bit of a video of that. And people experienced a relation with her. When doing this in virtual reality, they feel something. There's something wrong in the relationship with her. She's angry at you. And people were talking about all the feelings she could have and how it reflected on them. And that's strange, because actually what happened here is that the girl is just animated randomly. The head movements are quite random. The eye movements are generated. There is no actually behavior or state of mind behind it. Oh, it stopped already. Okay. Yeah, there she is again. So this is a very interesting thing, because that makes the difference between artificial robotic people and real people. So that's what I'm going to talk about a bit more, because the technology behind it is actually quite simple. If I can now. So for example, the girl is looking around for interesting things. Yeah? That can be an object like the speaker. It can be people. People are looking a lot to people. And for example, I tried to scan the whole room over here and give everybody enough attention. But it's all dependent on all kinds of triggers for me, from why I am looking at this girl or that guy instead of the other one, and how long am I looking to that. That is all dependent on all kinds of scores, and I listed 3 of here, which is about how close are they to me. Are they very close? Are they actually touching me? Or are they 20 meters apart? They are more or less interesting for me. Are they moving or just sitting still? Are they talking? Are they talking to me, for example? And all those scores are continuously calculated and determines for me to who am I looking at that moment. So this is constantly going on and changes the things the people are looking to. Another thing is saccades. Actually, when you are looking at someone, you can already see that you're not constantly looking at their eyes. It's very creepy when someone constantly looks at your eyes. In fact, as you can see on the picture on the right, it's done with eye tracking. Oops, I should be careful. We're looking at eyes, yes we do, but we also look at mouth and noses and scan the face from that too. And even look at the chest, look away from times. If you do that, it makes you more human. You're not robotic. And this is actually the trick which works the best also with the coffee with words. If you switch this off, she becomes a robotic immediately. So it's very tiny things which are generated, not animated behavior, which makes artificial people more human-like. Okay, then I move to the third subject, physics. Physics in animation is a hard thing. When you have an animation in a 3D environment and it animates that the arm is moving like this, and actually when the guy with the animation is placed next to a wall, the arm will move through the wall, because that's what the animation says. It actually, it's not very realistic, but it's the best we can do right now. And you see it also in the physics engines of 3D environments, like which are present in the Unreal or the Unity engine. What you see is that I can have a rigid body collider, which is just a ball or a bottle, which is just in free space and is only driven by physics law. And they can collide with the ground, static objects, or collide with each other. It's implemented very well and it works very well. But now I have a kinematic object, which is, for example, my hand. A kinematic object is not driven by physics, but driven by external input. It can be an animation. It can also be procedural with computer code. But when you drive an object position directly, physics doesn't work. I don't have collisions with static colliders, and even kinematic objects cannot collide with each other. So if you do this, like I showed in the animation, they move through each other. And yeah, well, that's easy, but not always the most realistic thing. So what I do in my software is I take apart the tracking position and the position of the avatar. So the tracking position is, for example, my hand. I'm tracking that my hand is here. But the position of the hand of my avatar, but I still have the same force. So when I press against a virtual wall in virtual reality, I get a force. This force can be used to move all kinds of heavy objects. For example, when there's a heavy object in front of me, I have to push through it to move it. If it's a very light one, I don't have to push a lot. But with a heavy one, I have to push a lot through the object. And in this way, you can actually have an interaction which is quite realistic. People, when I'm doing this demo, actually have experienced weights. So I've had 4 blocks ranging from 100 grams to 10 kilograms, and in virtual reality. In real, they didn't exist. So when they pick up the first block, they see, oh, it's light, tracking very good because it's one-on-one. And then they move on to the heavier blocks. And actually what happens when they have the very heavy block, they have to move like this to lift it. That's actually stretching the arm fully up in order to lift it just a little bit. The distance between the tracking hand and the avatar hand should be large to get enough force to lift it. And afterwards, I asked them, did you know you were standing like this? No, they don't realize that. At the same time, people report that they are actually feeling weight. That's not possible because you didn't have anything in your hand. You were just standing like this. That's not weight. But because it looks like a heavy object, everything you see is actually like real life. The mind takes it as being real. And actually, the mind feedback is actually, this is a heavy object. Even though your muscles don't tell you that's a heavy object, it still gives you the signal that it's heavy. And it overrules, basically, the input you get from the muscles. And so you can get very interesting interaction for tracking. So actually, this is the code which comes with that, a very basic version of that. So you see the hand target and the hand rigid body. Actually, the difference of that is multiplied with the strength. So some people are stronger than other people. And that's applied as a force to the hand. It's actually when you push to the wall, you're calculating this force. And it's a very simple rule, but it's a very powerful rule. And I see I have a little time left, so I can even try to show it. But today I had some troubles. So I hope it works well. And there's my mouse. Yay, it's still tracking me. However, I'm not at the right position anymore, because actually this is a perception neuron. Like I said, it's tracking not positions, it's tracking rotation. So actually it doesn't know exactly where I am. And because of there's magnetic sensors inside, it drifts away. So when I start tracking here, I can be there in 10 minutes. And that's actually what's happening, because it's not underneath the blocks anymore. So I have to reset my position, zero it out. You see I'm jumping back to the origin. And now go back to Unity. Where's my mouse? And now I should be able to actually lift the box. The colors of the boxes are actually representing the weight of the boxes. So if I lift a light box like this one, I can push it upwards very easy. And there's something strange going on with my arms and hands. I discovered it just at the beginning of this presentation. It's not good, but yeah, I couldn't do anything about it. You can see that actually when I'm trying to lift a black one, it's very hard. And you can even hear from my voice, I subconsciously try to I actually try to push harder. There's no thing of pushing harder, but my mind is telling me you should push harder to lift it up. So everything is actually doing like you're pushing heavy things. And that's a very interesting thing happening especially VR. A lot of things come from virtual reality, but nowadays I see more and more interest coming from all kinds of environments, from motion capture, but also interactive animations and film, for example. So that's why I'm creating now packages which are not dependent on virtual reality, but just on animation technology at the beginning. And my left leg is not tracking. That's because somewhere it's disconnected. So let's go back to physics. So that's basically what I want to talk about. There's a lot of things more that I could talk about, but basics of motion capture, artificial behavior, and physics are interesting things in the field right now happening, which are actually completely transforming the field, and gives you a lot of new possibilities in human character animation, capture, film, and so on. And things will be totally different, I think, in a couple of years, where just animation is more and more replaced by more advanced ways of driving virtual people. So if you want to know more, you can contact me. I am happy to talk about it a lot more, because there's a lot more to talk about. For example, facials. I haven't talked about faces anymore. Well, you can spend a couple of 8 minutes, I think, spent asking questions now. You could also take my business card later on or contact me from the website. So thank you, at least, for coming here. It's nice to have a good audience. Do you have any questions? Yeah.
Is the product on the market, or is just? Is the product on the market, or is just still in progress?
No, the virtual reality product, the instant VR product, has been on the market for 2 years now. In this month, I will be releasing the humanoid control product, which is oriented to a much wider audience, and it has more tracking capabilities. Other questions? No? Okay. Then I would like to thank you and have fun the rest of the day. Okay?